beware of dog, cross off dog, beware of the forbidden rule sign. Saw a lot of beware of dog signs over the weekend as I went around town. I even saw one on a truck at Walmart with a pit bull staring me down, and on the truck it said beware of dog. I'm like, that dog could jump out and get me. Anyways, okay, so let's see if any of you broke the forbidden rule on accident. I know I saw at least one person start to do it right, and then they went kind of backwards and started breaking the forbidden rule. So how do we need to rewrite this, guys? X minus 2 times, okay, times x minus 2. It would be breaking the forbidden rule to just go x squared minus 2 squared. So that would have been x squared minus 4. If you did this, you got it incorrect, not right. That's breaking the forbidden rule, guys. So you have to do it like this, and then we have to double distribute. Some of you learned it as FOIL. I don't use the word FOIL because that's learning a acronym instead of the math. We're gonna double distribute. So x times by x and becomes x squared. Let's help me out today, guys. X times by negative 2, be careful. All right, you guys are awesome. Negative 2 times x. Negative 2x, very good. And then negative 2 times negative 2, very carefully. Positive 4, very good, guys. Okay, now combining my terms, you're carefully getting better at this, not just assuming things, jumping to conclusions. You're looking at it and doing the math, which is awesome. So we have x squared and then minus 2x minus 2x. Good, negative 4x. I'm glad you didn't say those two things cancel out before thinking about it. Because you're right, negative 2x's minus 2 more x's is negative 4x plus 4. How many of you got it 100% correct? How many of you were close? How many of you just made a little error and now you've realized? Okay, awesome. That's what matters really more than anything, okay? Because as you've seen, if you've been watching your grade, I'm pretty generous for the most part with my point giving on these, if you were pretty much right. All right, awesome. Any questions on that? Okay, let's get started on the new stuff. First of all, we're just going to quick hit a few things that you should already kind of know. I just want to make sure you're good to go for like an activity. We're going to do competition in our teams today, and then we'll get to some learning some new stuff, or just kind of, yeah. So we're going to be today just kind of looking at graphs. On the front of your worksheet, you can see that you're going to be looking at a bunch of different graphs, all different types of graphs, and we're going to be describing them today. So we're going to have to get good at describing a graph. So what we're going to focus on today is shape. Then if a graph is increasing or decreasing, or it could be both, it's increasing and decreasing as well. Also, we're going to talk about x and y intercepts, where it crosses the x and y axis, and if it's truly a function. So just because we have a picture of it doesn't mean it qualifies to be a function. So we've got to tell if it's a function for sure. And then we're going to talk about if it's a continuous graph or a discrete graph, whether it's a function or not. So we're going to just quickly go over these things and what they mean, and then I'm going to have us do a little competition together. Okay, so first of all, we're going to focus on shape. Today I'm going to have you stay super basic. I'll take pretty much anything you see. Just I want you to tell me what you see. We are getting a little bit more advanced though, so with some things I want us to try to use the correct words if possible. I won't be super strict today. But this right here would be a line, for example. You guys all know what lines are, so you need to say a line. That's a positive line, right? An increasing line. If we look from left to right, does everybody see how it's increasing? If you look from left to right, you can definitely see how you'd be walking up a hill. Okay, now looking at this is a parabola. I'll take the word U-shaped, but for you advanced thinkers, it's called a parabola. So, if I remember how to spell it, parabola. Yeah, parabola. Yeah, I think that's how you spell it. Okay, parabola. So also I'll take a U-shape today, because we're gonna stick pretty basic today. This right here is a sideways U-shape. I'll take that. It's a sideways U-shape. We're staying way basic today. The other teachers stayed basic when they taught this lesson. I'm going to stay pretty basic for the most part. Now notice like this is a sharp V. Does everybody see the difference between a parabola and a sharp V? This is called an absolute value graph. We will be dealing with these this year. It's called absolute value. So this is an absolute value function, and we will be dealing with these later on. Sharp V versus parabola, very, very different graphs. Even though they kind of look the same, they're not. And then this over here is called a root function. This is a root function, a square root function actually, but I'll take a half u for today. So if you want to call this a half u, I'll accept that for today. Now in secondary 3, we get heavily involved in graphing these type of things, so I would make them use the correct words. We will graph these somewhat in here. Anyways, just keeping those little things in mind. For shape, where I just want to see, you tell me what you see. A U, a V, a half circle, a full circle, whatever you see, all except for shape. It's just getting you thinking. Okay, so now we have to decide if functions are increasing or decreasing. So with these, I know I'm kind of going fast, but you'll get to practice these. So for the most part, if you want to just watch this, take little notes, that's fine. But looking really for this part, watch them. It's going to be more beneficial for you to watch. So with increasing and decreasing, guys, you have to look from left to right. Always look from left to right. So you can usually tell pretty quickly if you look from left to right if a function is, or if a graph is increasing or decreasing. So looking at this one, from left to right, it's what? Increasing. I'm going to put an I for increasing. Now, once again, from left to right, is this increasing or decreasing here? Decreasing. Look, if you got on that, like if you were a person and stood on that, you'd slide down. So it's decreasing. Very good. Looking at this view over here, this parabola, it's a flipped upside down parabola. It kind of looks like a frowny face, notice. Is it decreasing or increasing? Okay, I can see why you'd say both. So you see that here it's decreasing, then it comes up increasing and going back down decreasing. I think for this one, I can see what you're saying. You're right. I can see what you're saying. We'll just go decreasing since both the ends are going down. So I'll take just decreasing on this one. Does that make sense, everybody? Okay. Now looking at this one, it is increasing and decreasing, but if we want it to be technical, looking at the end behavior, if I'm talking end behavior, then it would be increasing, right? It's getting larger and larger and larger. Okay, and then this one, once again, if we look from left to right, let's be really basic today. Left from right, is it starting small and getting larger, even though it bounces? Yes, so this would be considered increasing. Questions on that? Okay, so we're staying basic with this next thing here. Okay, so x and y intercepts. Today you're going to be able to just look at a graph and say, okay, I can see the x and y intercepts. Where it's crossing the x-axis are the x-intercepts. Where it's crossing the y-axis is the y-intercepts. It is exactly what it sounds like. X-intercept, intercepting the x-axis. Y-intercept, it's intercepting, crossing the y-axis. So you're just going to eyeball it with these. Now, interesting fact though, later on, we're going to learn how to take a quadratic and factor and solve for the zeros, meaning the x values, and then you'll know exactly where it crosses the x-axis. On a line, when you solve, we're finding where it crosses the x-axis. So interesting enough, that's what we're actually doing when you're solving. Anyways, today you're going to be able to eyeball it. So looking at this, for example, looking at my picture up here, just look at it with me, probably is the best. Let's see, first of all, let's look at the x-axis and find out the x-intercepts. So that means where it's crossing the x-axis. So let's look over here on the left first. Where is it crossing the x-intercepts? You guys are kind of far away. It's kind of hard to see. Can you see where it's crossing the x-axis? -5. So an x-intercept is -5. Very good, right there. It's crossing the x-axis. And then at what? Where else? At 10. Okay, so our x-intercepts are at -5 and 10. And then our y-intercept. Now we're looking up and down. Where's it crossing the y-axis? -8. Very good. -8. So we're just going to be able to eyeball it today, which is nice, and it's really helpful. But most of the time in our future, we have to do this using algebra instead of just eyeballing. But today, we will get to eyeball it. All right, looking at this graph, what's my x-intercept or intercepts? Where's it crossing the x-axis? It's crossing, touching down at -8. That's the only place that's crossing the x-axis. My y-axis, how about that? +6. Good. So we're seeing that. And then last one here, looking at over here, what are my x-intercepts? Anywhere it crosses the x-axis. What about right here? What is that? Good. -7.
4.
Oh. Is that, what is that? Negative what?
3.
-3. Okay, so make sure you put the negative. And then right here. +3. Very good. And my y-intercepts at -6. Yeah. Perfect. Crossing at the y-axis at -6. Questions on that? Just we get to eyeball it today. Pretty basic. And then we're getting down to the end here. Now this is where the hardest part is probably because it's hard for students at your guys' level to see this at first, but we'll get better. We're going to look at these and decide if they're truly a function. So what makes something truly a function, guys, is that every single x only has one y value. Every single x value only has one y value. So, have you ever heard of the vertical line test, anybody? Even if you don't know what it is. Anybody heard of the vertical line test? Yeah. So that's like one thing that's not a mathematical thing. It's just something that people use as a trick. So what you do is you go through and you can hold your pencil as your vertical line. If you hold it vertical and trace it across like this, if it touches your pencil on the y-axis in two places, where your pencil is sitting at one place, it's considered not a function. Okay, so looking at this, it's easier for me to show you by drawing a line. So right here, boom. If I draw a line, does it hit? Does that like function, graph, whatever, graph hit my pencil in two places when my pencil is at one? Right there, it hit it, and right there. Does everybody see how that would be considered? So that's considered not a function. If I draw a line right there, once again, it's hitting my pencil in two places. That's not good. That's considered not a function. So this one would be considered not a function. But look at this one. If I went through and draw a line, it only hit it once, right? Draw another line. If I keep going, line, only hit it once, hit it once, hit it once. And this is going to continue to grow that way, and it's going to get steep, but it's never going to like come back on itself. It's going to continue in that direction forever. And same with this. So it's never going to hit my pencil twice if I drew a line anywhere. So that one's considered a function. Looking at this one, once again, if you draw a bunch of lines to see, it only hit my pencil once. Hit my pencil once. Hit my pencil once. Once. And once again, it's going that way forever and down that way forever. So this one will always only hit my pencil once. So that would be considered a function. The vertical line test. Okay? So everybody see how it hit it twice here. That's the most important part. So you can always test every single function. If you need to sit and draw lines and say, is there anywhere it's going to hit my pencil twice? Then the answer would be no. Okay. And now we have to learn the last thing, which is continuous or discrete. So a continuous function, guys, means it's continuing forever in both directions, and there's no breaks. There's no breaks. It means all the x's are connected. So we got to talk about a few things real quick. If it's continuous, it will never disconnect. It's going to continually be on the x-axis forever, and it's going to continue in both directions. But if it's discrete, it's going to have breaks in it. And it's going to have missing x gaps. So looking at this one right here, this would be considered continuous because notice there's no gaps. It's going forever and there's nothing breaking it. So that's continuous. I'm going to just abbreviate that. Now looking at these dots here, now notice there's a bunch of gaps. There's nothing right there. There's nothing right there. There's nothing right there, right there. So there's gaps. This would be discrete. It's still a graph. It's still a function, but it's a discrete function, meaning there's gaps. It's not filled in everywhere. So looking at this line, do you think it's continuous or discrete? Continuous, good. Now this one's tricky. That's why I'm showing you it. This one's really tricky. So the normal student, even I, had to say to myself, is this one continuous or discrete? Let's think about it for a second. So I sat and thought about it, debated, and then I came up with an answer, and I checked with my book to see if I was correct. And I said discrete, and then it hit me. No, it's continuous because, guys, everybody look at this one. Even though this one has breaks, and I can't draw it very perfectly on here, even though this one has breaks, notice the x values are filled in everywhere because look, if I trace along this red line, yeah, it breaks, but notice the red line starts right where that x value stopped. So does everybody see how it still has an x value exactly in the right spot? So it's technically still, like, once again, even though it breaks, it's reconnecting because it's touching back at that same x value. So if it's touching at that same x value, then this is considered continuous because there's no gaps of x's. Does that make sense? Kind of. That's pretty complicated. To be honest, I was surprised that they threw that one at me. All right. Do you feel okay? Okay, we're going to work in our teams. This is the competition. So you're going to do your front page together. When you've come up with your full answers, raise your hand, have one person. I'll check one person's in the group. So I'm going to choose some random person. You're not going to know who I choose. So you need to all be working together. You're going to decide the shape, if it's increasing or decreasing, the x and y intercepts, if it's truly a function, and then if it's continuous or discrete. So make sure you write your answers clearly because I'm going to pick one person, and I'm going to check your answers. And the first group to get them correct wins, okay? Now, I'm going to allow for one mistake. So if you get one mistake and that's it, your team can still win, okay? Because this is supposed to be a learning experience. So ready, set, go. Okay, so hopefully that fun and just good for you guys to see, and it's good practice because on an ACT or on an end of level or even on the quiz on Friday, I might say, tell me if this is a function, tell me if this is increasing or decreasing, etc., etc. So it's good practice. Okay, so now I just want us to get our brain kind of thinking. These ones are kind of hard because there's more than one right answer. So everybody just look up here with me for a second, and then I'm gonna let you work for a little bit. But looking at this, now we're gonna have to use our kind of common sense and think through what something would look like. So it's kind of hard for me to teach because there's not gonna be an exact right answer. Like I can't just say it's always this way. You have to kind of use your brains and kind of think through it. So looking at this, for example, this is just an example of what you guys are going to see on the worksheet. It says, match the graph to the correct scenario. So I have a lot of students say, well, it's hard because there's not one exact correct answer. You do your best, and that's all we can do sometimes, but we have to just think critically. So, for example, it's giving us A, the price of gas over the past decade, and it's giving us B, heights due to age. And then we have the options of these two graphs. We're going to match them to these two graphs. So you have to kind of think about it in the real world and say, what do these look like? Like, what do these things look like? So the price of gas over the past decade. So think about gas back in the day. Started out really low, right? Just kind of average, low. And then all of a sudden, it started to get really, really expensive. And then it got really expensive. And then it kind of evened out. And for a while now, it's kind of been evened out, right? So I would say that this would go with graph A. Now, the reason I might change my answer, but let's look at our other graph and think about that. So height due to age. So you think about height, guys. When we're born, we grow exponentially, right? When you're first born, it's like, holy cow, these babies grow so fast. So you're getting really, really tall, really quite fast. And then once we hit a certain height, like in high school or right after high school, we kind of stay the same height our whole lives, right? And then sometimes, though, when we hit old age, we kind of drop down, but we never are going to sink back down to where we started, right? We're never going to become a baby's height. So does everybody see, though, how we could kind of do our best at saying which graph matches which picture? With these guys, you have to just do your best and think through them. I can't teach you how to go about every single one because there's not always one correct answer. So just thinking through something like that with you hopefully will help a little bit. Okay, so now this is the part that is really interesting. You guys are going to use this forever, and you're going to love me for it, okay? How many of you, let's be honest, okay? You can be honest with me. I can be honest with you. How many of you hate when you're asked to make an XY chart given a function? You have to plug in a bunch of values for x, right? Some of us hate doing that. You plug in -2, you calculate it and get your y value. You plug in 0, then you get your y value. You plug in +1, you get your y value. It takes forever. Your graphing calculators will do it for you. So I'm going to teach you how to do that now. Why not learn to use these beautiful things that we've paid so much money for? So everybody get out your graphing calculators. If not, just watch. And then there is somebody at your table today that you can work with. And then you'll get that here shortly, okay? So everybody look how cool this is. So notice it says using a graphing calculator, what are the XY points of y is equal to -2x plus 1? Now if you want to do it by hand, you can make an XY chart like this. You'll still be making one. It's just your calculator is going to do it for you. And then you'll just plug in a bunch of values and you'll calculate. But I'm going to teach you how to use your graphing calculator. So everybody follow me through this. So here's my graphing calculator. Now the function was y is equal to -2x plus 1. That happens to be our function right here. -2x plus 1. So I pull up my graphing calculator. Now up here, notice there's a y equals key. That's where you go to type in a function. So you're going to hit the y equals key. And I'm in a window that looks like this. Is everybody there? Okay, so now you type in. Now right down here is the negative. You cannot type in. And most students, when they start out using the calculator, they use the minus sign for negative. On a calculator, they have a specific negative key. You can't use a minus sign, or else it will say error. So if you ever see the word error, say, oops, I accidentally type in a minus sign instead of a negative. So we need to type in -2. And then to type in x, notice right here on this key right here, that's where you can type in a variable. So -2x, and then was it what? Let's see, +1. So -2x, is everybody there? And then you just do +1. Is everybody there so that I'm not going ahead? Now we could hit graph and look at what the graph looks like. Kind of interesting. So now looking at this graph, we see exactly what it looks like. So let's say on a test you needed to match a graph to a function. We could do it one of these two ways, but we have to be careful. Anyways, Okay, so now to see the XY table, to see the values, you'll hit the second key, this blue key right up here. Yours might not be blue, might be yellow. I'm not sure. So you hit the second key, and then notice we want to hit graph again, but if you notice up here in the little saying, it says table. So the second key, and then hit graph, because that means go to the table. Now look, there's my XY points. Now if you plugged in the XY points, you'd get the same answers for Y. You'd be just doing it algebraically versus using your calculator. So whatever way you prefer, but really this way you can check your answers even if you want to do it by hand. Now let's say I want to see back up here into the -1 direction, because notice this is x is equal to 0. So look, if we plugged in 0, guys, we would get 1. If we plugged in 1, we would get -1. If we plug in 2, we'd get -3. Let's say we want to see higher up into the negatives, we could scroll up. Because like I said, guys, I want to see on your XY chart at least a -2 to a +2. So I'm going to write that down. You guys keep your calculator up so you can tell me what values you see. So I want to see at least starting at, so -2, -1, 0, 1, 2. You could go ahead and plug all those in, or you could use your calculator and it will tell you what you would get if you plugged them in. What'd you get when you got -2? 5. What'd you get when you plugged in -1? 3. What'd you get when you plugged in 0? 1. And that makes sense. You could even check it. What if you would have plugged in 1? -1 and 2? -3. So that was way quick, right? Way quick. So now let's use that information to match a function to its table. So let's go backwards really quick. Everybody go to your y equals key and type in 2x squared. So everybody, it says what graph matches what table. So you're going to type that into your calculator. I'll bring it up really quick to make sure we're good with that. So I'm going to go back to y equals. I'm going to clear that out, hit clear, and then I'm going to type in, it was -2x squared, right? Let's see, was it just +2x squared? Yeah, +2x squared. So I'm going to type that in. 2, and then x, and then the squared key's right here. But if you needed to do ℏ2, that would work too. Does everybody know how to plug that in? That was kind of quick. So are you all following? So that I know you really know how. Now I could hit graph if I wanted to see what the function looked like, but also I just want to see the table. Now notice in my window I can see the table over here, but let's say I couldn't see that. You hit the second key and then hit graph again because that means table. Now here are the new XY points for that. So -2, 8, -1, 2, 0, 0, 1, 2, 2, 8. So I'm going to look at my tables and see which ones match up. Now I noticed on the worksheet the tables weren't always in order, which is kind of annoying. So I just wanted to practice this. Okay, so look at your -3 point. What did you get on your graph? 18. You got 18, so we know for sure it's that one. Does that make sense? So this is that one. If you look at -1, I checked more than 1 point. If you put in -1, if you look at your -1, did you get 2? And 0, 0. Okay, so we know that for sure goes to that graph. Now let's teach you really quick how to type that into your graph, your calculator really quick. So notice it's y is equal to 3 times 2 raised to the x power. So the x is up in the exponent on this one. We'll get into graphing these by hand later in life. All right, so hit y equals, now it was 3 times 2 raised to the x. Is that true? So 3 parentheses times 2, you've got to put the 2 in parentheses because it's the 2 raised to the x, not the 3. So 3 times 2 raised to the caret sign means raised to the, and then I'm going to put in the variable x. Then I'm going to hit graph just to look at it. Okay, it's a exponential function. We will get into that in this course and not too many lessons away. Anyways, and then I'm going to hit table, so second graph, and then I can look at the table. Now, once again, if I look at -3, it's 0.375. If I look at -2, it's 0.75. If you look at -1, it's 1.5. And so we know that it is this graph. If you look at +1, is it 6? Everybody? Yes. Okay. Does everybody get how to use your graphing calculator? Okay, last thing, and then I'm going to let you work the rest of the hour, so you'll still have 25 minutes, so I want you to stay with me. Last thing. A lot of people are skipping these on the homework, and you have to know how to do these. Guys, I put review problems on there to make you successful. And if we don't practice these a lot, you won't be successful. You'll forget these things. So let's quickly go through this one together, because guys, you can't skip the review problems. You're handing in assignments with review problems skipped. If you are doing that, I'm going to be calling you into CAT time to finish them. They're really important. I really don't put anything on there that I don't feel it's important. I cut out a lot of problems because I'm like, that's a pointless problem. So every problem I put on there is really meaningful, okay? So let's go through this one. Remember that area is equal to length times width, and I was just write it, area is equal to length times the width. Now that works for rectangles, that works for squares. Now these are area squares, meaning you're going to be given sometimes the outsides, the insides. The inside's the area, and then the outside's the length and the width, the dimensions. So you have to use critical thinking to go through and fill these in. So first of all, looking at this, okay, I have the area 6, I have the area 15, and then I have the side length right here, which is 8, and then this side length, which is 2. Well, if we have those two side lengths, can't we just do length times width and find the area in here? Now if we're trying to fill all this in, yeah? Everybody, do you see what I'm saying? Length times width. Let's fill in the area. What's 8 times 2? 16. Very good. Now let's keep using critical thinking for a second. A lot of people say, I don't get these, so you should be watching carefully. If this piece is 2, that piece is 2, then notice this is the same length as that. So this must be 2. All right. Questions to there? So now I'm thinking, okay, so this times this was equal to 6. That times that is equal to 6 because that's length times width. So 2 times question mark is equal to 6. What's question mark? 3. So we know that 2 times 3 is equal to 6. Good. Questions on that? Now I'll switch colors again to purple, sure. If this side is 3, then this side for sure is 3 as well. Okay, so once again, length times width is equal to the area. So 3 times what is equal to 15? 5. Okay. So that's 5. We're getting there. So if this length is 5, then this length is for sure 5. Very good. Okay, but I don't have that side, do I? Good. It's 8. So you look around and say, well, where could I get that side from? Well, we know this side's 8, so this side is for surely 8. Then 8 times 5 is 40. Now this is not drawn to scale, and in this course we have to use math versus what the picture looks like every single time. So yeah, this you're like, well, how is that 40 and that's 16? They look the same size. It's because it's not drawn to scale, meaning they're not going to draw it to fit the picture. They want to see if you know the math. And in your future mathematics after this course, it'll always say that. I mean, it will always be that way. They want to see if you know the math, so they'll try to draw a picture to trick you because you have to use the math. Now, to find the area, we can add up all the insides, right? Everybody? Okay. Does everybody get how to do an area square? Good reminder. Now, you have the rest of the time to finish this worksheet. Now, notice you're going to skip problem 1-65 on there and 1-54. We're going to learn in a few lessons about exponential functions, and that is an exponential function, exponential growth and decay. And then if you don't know how to do 1-52 is what we just learned for the calculators. So you'll use that for the calculators. So everybody should be good to go. Everybody should be good to go. You can cross those out. I have a completely different worksheet with those on it, so it's okay to cross out those problems so you don't forget to not do them. 1-65 and 1-54. I promise we will learn them in a few lessons. I think it goes better with a different lesson that we're going to learn. So anyways, go ahead and finish. Work till the end of the hour. You have plenty of time. Hopefully you'll finish and not have homework, right?